To truly understand artificial intelligence, you must look past the pop culture myths. AI isn't magic, it's a distinct method of solving problems. Think of traditional programming like baking with a strict recipe. As a developer, your job is to write explicit step by step instructions. This diagram represents the logic that has powered the digital world for decades. You give the computer the raw ingredients, the data, and the exact steps to follow the rules. The computer executes these rules to give you an answer. As long as a human programmer can explicitly define every single step of that process, this linear system works flawlessly. But the physical world is messy. Eventually, we run into tasks that defy simple step by step instructions. Imagine trying to write the code for driving a car through a chaotic city intersection at night, surrounded by unpredictable pedestrians. If you forget to tell the program how to handle one specific rare edge case, the entire system breaks. Human logic simply cannot write enough if-then statements to capture reality. Getting past this barrier required a shift in how we approach computing. That shift is machine learning. It was designed specifically to break through the complexity ceiling of traditional code. Researchers took the original logic of computing and flipped it. Instead of providing rules, we feed the system massive amounts of raw data paired with correct answers. Then we task the computer to process this information and figure out the rules on its own. We are no longer instructing the machine on how to do a task. Instead, we are asking it to discover the underlying logic itself. Let's return to the bakery. Only now, instead of writing a recipe, you are a master baker training a blank slate apprentice. You feed the apprentice thousands of cakes, explicitly pointing out which ones taste great and which ones fail. Over time, the apprentice analyzes these examples independently. It learns to identify subtle patterns that make a great cake. Patterns a human might not even know how to put into words. The rules of the AI are hidden patterns extracted directly from the data without human intervention. This independent pattern finding ability allows software to handle tasks like translating language in real time or recognizing a specific human face. Because the system isn't brittle, it can dynamically adapt, learning from new data to handle the messiness of the real world. This changes the role of the developer. Rather than acting as an instructor writing explicit rules, the developer becomes a curator who manages the data. Traditional programming relies on human logic to process data, while AI uses data to learn human logic. This inversion is the basis for how we build machine learning systems. In upcoming lessons, we will look at the major branches of this technology, starting with narrow AI. From there, we will explore the theoretical limits of general AI and the layered depths of deep learning. With this mental model of inverted logic, you can now begin to see how the most complex systems in the world are built.